Okay, good morning students. Today we'll start, that is chapter number 14, Oscillations. And before going to start, we'll start about one of the important concept belongs to the topic else, that is periodic motions. First we'll start, what do you mean by periodic motions? Periodic motion or motions you can write. Before going to start a detail about oscillatory motion, first you need to know about what is the meaning of periodic motions. Periodic in the sense that is with respect of time, the motion of the object that should maintain a constant time period. Let us take, first we will see the definition of the periodic motion. What is that one? The periodic motions are nothing but, these are the motions which repeats themselves with regular interval of time. The definition, that is a motion which repeats, a motion which repeats itself, a motion which repeats itself with regular interval of time, repeats itself with regular time interval or regular interval of time, with regular interval of time, regular interval of time, interval of time called periodic motions, called periodic motions. Periodic motions. In order to understand the definition of the periodic motion, I will take an example as, the example for periodic motion is, that is revolution of earth, around the sun, revolution of earth around the sun, this is a periodic motion. And here the word is revolution is there. What is the difference between revolution and rotation? Are the words are same? Not. The revolution is different and rotation is different. As you know very well, if the body is moving about its own axis, then we are going to call it as a rotation or spinning. But revolution is different. The object which is moving around another object, that is called as a revolution. ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ತನ್ನ ಸುತ್ತರಿಗೆ ತಾನೇ ಸುತ್ತಿದ್ರ ಅದು ರೊಟೇಷನ್ ಅಥವಾ ಸ್ಪಿನ್ ಮೋಷನ್. ಯಾವುದೋ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ಅನದರ್ ಆಬ್ಜೆಕ್ಟ್ ಅನ್ನ ಗೆಟಿಂಗ್ ಯಾವುದೇ ಬೇರೆ ಆಬ್ಜೆಕ್ಟ್ ಅದು ಸುತ್ತರಿಗೆ ಸುತ್ತಿದ್ರ, ದಟ್ ಈಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ರೆವಲ್ಯೂಷನ್. The rotation and revolution both are not same. The rotation and spinning motion are same, but revolution is different and rotation is different. A body which is moving about its own axis is called as a rotation or a spinning motion. The body which is moving around the another object is called as a revolution. For example, the earth is moving around the sun is not a rotation, that is a revolution. And earth is moving about its own axis, that is called as a rotation or spin. The example, revolution of earth around the sun, this is example for periodic motion. And let us take here, in elliptical path the earth is revolving around the sun. This is earth and this is the position of sun. This is the position of sun. Let us take, this is the axis, this is major axis, this is minor axis, and here this is the position of sun. This is the position of sun. Now earth is revolving, the earth is taking revolution around the sun. Imagine from this point the earth started its journey. In order to take one complete journey or revolution, it take 365 days. Again for second journey it is repeating itself only. Again for second revolution it is taking 365 days as a time. Again for third revolution it is taking the same time. Again for fourth revolution also it is taking 365 days as a time. Again for fifth revolution also it is taking a same time, that is 365 days, means 1 year. You think yourself, what is the time taken by the earth to complete one revolution? That is 365 days. Time is equal to 365 days. For first revolution, this much time taken by the earth. For second revolution, the object itself is moving. And is the person is applying any force to the earth for the second revolution? No. The object is taking revolution around the sun, and again one cycle is completed. For second cycle, the object itself it is moving. For one cycle, this is the time. For second cycle, this is the time. For third cycle, this is the time. For fourth cycle, this is the time. The time taken by the earth taking around the sun to revolve, that is constant, that is 365 days. A motion is repeating continuously. A motion is repeating continuously with constant time. Constant in the sense that body, earth is a body or the object is, it is taking constant time for each and every cycle around the sun. Therefore, periodic motion in the sense a motion which repeats, means after one completion of the cycle, second cycle earth is only repeating itself. Which repeats, which means object repeats. Object repeats after completion of one cycle, second cycle itself it is starting. It repeats its motion continuously with regular interval of time. Regular means the time interval, the time taken by the body for each and every cycle should be same. For first cycle, this is the time. After completion of first cycle, the body itself started its motion. For completion of the second cycle, again it is taking this much of time. Again for third cycle itself it is going under the motion. For the completion of third cycle also it is taking this much of time. Then you think yourself, what is the time taken by the earth for each and every cycle around the sun? That is exactly constant, T equal to 365 days. Regular interval in the sense that time is constant for each and every cycle around the sun. This motion is called as a periodic motion. ಯಾವ motion sir? Getting a motion which repeats. ಆ motion ತಾನಾಗೆ ರಿಪೀಟ್ ಆಗಬೇಕು. ಪ್ರತಿಯೊಂದು ಸೈಕಲ್ಗೆ ತಗೊಳ್ಳುವಂಥ ಟೈಮ್ ಕಾನ್ಸ್ಟಂಟ್ ಸೇಮ್ ಇರಬೇಕು, ಕಾನ್ಸ್ಟಂಟ್ ಇರಬೇಕು. ಅಂಥ ಮೋಷನ್ಗೆ ಏನಂತಾರ? ಪೀರಿಯಾಡಿಕ್ ಮೋಷನ್ ಅಂತಾರ. ಒಂದು ಸೈಕಲನ್ನು ಕಂಪ್ಲೀಟ್ ಮಾಡಿದ್ಮೇಲೆ ಸೆಕೆಂಡ್ ಸೈಕಲ್ ತಾನಾಗೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೋತದ. ಒಂದು ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಆತ, ಎರಡನೇ ಸೈಕಲ್ಗೆ ಯಾರಾದರೂ ಪರ್ಸನ್ ಬಂದು ಮತ್ತೆ ದುಗಿಸ್ತಾನ? ನೋ. ಈಸ್ ದ ಪರ್ಸನ್ ಅಪ್ಲೈಯಿಂಗ್ ಎನಿ external force on the body for the second cycle? No, highly impossible. The motion which repeats itself, the earth repeats for the second cycle itself only. ಫಸ್ಟ್ ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಮಾಡಕ್ಕೆ ಇಷ್ಟು ಟೈಮ್ ತಗೊಳದ, ಸೆಕೆಂಡ್ ಸೈಕಲ್ ತಾನ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಂಡಿರ್ತದ, ಸೆಕೆಂಡ್ ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಮಾಡಕ್ಕೆ ಸೇಮ್ ಟೈಮ್ ತಗೋತದ, ಥರ್ಡ್ ಸೈಕಲ್ ಇಸ್ ದ ಸೇಮ್, ಫೋರ್ತ್ ಸೈಕಲ್ ಇಸ್ ದ ಸೇಮ್. ಫಾರ್ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಜರ್ನಿ ಅಲಾಂಗ್ its path around the sun is exactly same. That's why a motion which repeats itself, a motion which repeats continuously itself with condition as regular interval of time. Regular interval in the sense the time taken by the body for each and every cycle is exactly same. That's why this is an example for periodic motion. And what is the second one? This is the first one. Second one, oscillation of a bob of simple pendulum. Simple pendulum. In the physics laboratory, you already done with this experiment, simple pendulum experiment. What is a bob? That is a simple pendulum. Simple pendulum in the sense that is an object having a high density, moving under the action of gravity. That body we are going to call it as a simple pendulum. Let us take it as an object. This is a thread. This is an object. This is support. This is a support. This one is a support, and this is a thread. This is thread, and this is an object. Pull the body to a certain point and release it, and it is doing a simple harmonic motion. Let us take it as a mean point. Means this is a reference point. This is mean point, and when the body is moving at this point, this displacement is maximum, and this point is called as a extreme point, and this point is also called as a extreme point, and this is also called as a extreme point, and this is a reference point, arbitrary point called as a mean point. And this is a bob. Pull the body to a certain point and release it, then it is moving like this. This is mean point, this is extreme point, and this is extreme point. And now the body, let us take, I am releasing at this point, pull the body here and release it, and it is going here. This is half cycle, again coming here, another half cycle, means half plus half. This is one cycle, one complete cycle. This is one cycle, this is second cycle, again third cycle, again fourth cycle, fifth cycle, so on continuously. Imagine yourself, I am releasing the body from this point, it is going here and again coming here. For reference you can take, to complete one cycle, the body takes time is equal to, for example, 2 seconds. Per second cycle how much it is taking? Again 2 seconds. Per third cycle it is taking the time is again 2 seconds. Again fourth cycle it started itself, and in order to complete fourth cycle how much time taken by the bob? Again 2 seconds. In order to complete fifth cycle, what is the time taken by the bob? Again 2 seconds. Sixth cycle again 2 seconds. Seventh cycle complete madak 2 seconds ತಗೋತದ. Per each and, for example, I have taken the time is equal to, that is a reference one, not a getting a standard value. ಈಗ ಒಂದನೇ ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಮಾಡಾಕ 2 ಸೆಕೆಂಡ್ ತಗೊಂಡಿತ್ತಂದ್ರ ಎರಡನೇ ಸೈಕಲ್ಗೂ 2 ಸೆಕೆಂಡ್, ಮೂರನೇ ಸೈಕಲ್ಗೂ 2 ಸೆಕೆಂಡ್, ನಾಲ್ಕನೇ ಸೆಕೆಂಡ್ಗೂ 2 ಸೆಕೆಂಡ್. For each and every cycle of this bob of the pendulum, simple pendulum, what is the time taken by the body? That is, for example, 2 seconds. For each and every cycle, what is the time taken by the simple pendulum? That is 2 seconds. The 2 seconds is the time taken by the body for each and every cycle. One cycle complete ಮಾಡಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೋತದ? 2 seconds. Second cycle complete ಮಾಡಕ್ಕೆ again 2 seconds. Third cycle complete ಮಾಡಕ್ಕೆ again 2 seconds. For each and every swinging, how much time taken by the body? That is 2 seconds. Then time per each and every cycle is constant or same. One cycle complete आता, second cycle ಇಲ್ಲಿ ಬಂದ ತಕ್ಷಣ ಸ್ಟಾಪ್ ಆಗಂಗಿಲ್ಲ, ಮತ್ತೆ ಸೆಕೆಂಡ್ ಸೈಕಲ್ ತಾನಾಗೆ ರಿಪೀಟ್ ಮಾಡ್ಕೋತದ. ಸೆಕೆಂಡ್ ಸೈಕಲ್ ಮುಗಿತಾ, ಥರ್ಡ್ ಸೈಕಲ್ ತಾನಾಗೆ ರಿಪೀಟ್ ಮಾಡ್ಕೋತದ, 2 ಸೆಕೆಂಡ್ ತಗೋತದ. ಫೋರ್ತ್ ಸೈಕಲ್ ತಾನಾಗೆ ರಿಪೀಟ್ ಮಾಡಿರ್ತದ, ಮತ್ತೆ 2 ಸೆಕೆಂಡ್ ತಗೋತದ. ಫಿಫ್ತ್ ಸೈಕಲ್ ತಾನಾಗೆ ರಿಪೀಟ್ ಮಾಡ್ತದ, ಮತ್ತೆ 2 ಸೆಕೆಂಡ್ ತಗೋತದ. The motion which repeats itself per each and every cycle how much time is taken by the body? Same time, means regular interval of time. Regular interval of time in the sense the time taken by the body per each and every cycle should be same, and the body getting repeats its motion itself only. That's why this is also example for periodic motion. Oscillation of a simple pendulum. This is oscillation. This is 1 cycle, 2 cycle, 3 cycle, 4 cycle. ಗೆಟಿಂಗ್ ಬಾಡಿ ಈ ಕಡೆಯಿಂದ ಈ ಕಡೆ ಹೋಗಿ ಬಂತ 1 ಸೈಕಲ್ ಆತ, 2ನೇ ಸೈಕಲ್ ತಾನಾಗೆ ಬಾಡಿ ರಿಪೀಟ್ ಮಾಡ್ತದ ಮತ್ತು ಸೇಮ್ ಟೈಮ್ ತಗೋತದ. ಇಮ್ಯಾಜಿನ್ ದಿಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಯು ಆರ್ ಡೂಯಿಂಗ್ ಇನ್ ಅ ವ್ಯಾಕ್ಯೂಮ್, ಅಂದರೆ ಏರ್ ಇರಬಾರ್ದು, ಏನೂ ಇರಬಾರ್ದು. ಯು ಆರ್ ಡೂಯಿಂಗ್ ದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇನ್ ವ್ಯಾಕ್ಯೂಮ್. ದ ವ್ಯಾಕ್ಯೂಮ್ ಇನ್ ದ ಸೆನ್ಸ್ ದೇರ್ ಇಸ್ ನೋ ಅ ಸಿಂಗಲ್ ಏರ್ ಪಾರ್ಟಿಕಲ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್. ಏರ್ ಪಾರ್ಟಿಕಲ್ ಇಲ್ಲ ಅಂದಾಗ ಒಂದು ಸತಿ ಬಾಡಿ ಮೂವ್ ಆಗಕ್ಕೈತಂದ್ರೆ until and unless someone has to stop it, the body itself never stops. Imagine the experiment you are doing in vacuum, not in a air. ನೀವು ಲ್ಯಾಬ್ ಒಳಗಡೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಿರಲ್ಲ, that is not a vacuum, that is a air medium. Air medium ಒಳಗಡೆ after some time the body stops itself because of air resistance. You imagine this experiment you are doing in a vacuum, ಅಂದರೆ ಏರ್ ಇಲ್ಲ, ಜಗ್ ಬಿಟ್ಬಿಡ್ಬೇಕಾ, 1 ಸೈಕಲ್ 2 ಸೆಕೆಂಡ್ ತಗೋತಾ, ಸೆಕೆಂಡ್ ಸೈಕಲ್ ತಾನ ರಿಪೀಟ್ ಮಾಡ್ಕೋತಾ 2 ಸೆಕೆಂಡ್ ತಗೋತಾ, ಥರ್ಡ್ ಸೈಕಲ್ ತಾನಾಗೆ ರಿಪೀಟ್ ಮಾಡ್ಕೋತಾ 2 ಸೆಕೆಂಡ್ ತಗೋತಾ, 4 ಸೈಕಲ್ ತಾನಾಗೆ ರಿಪೀಟ್ ಮಾಡ್ಕೋತಾ 2 ಸೆಕೆಂಡ್ ತಗೋತಾ. ದ ಮೋಷನ್ ವಿಚ್ ರಿಪೀಟಿಂಗ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಇಟ್ ಸೆಲ್ಫ್ and the time taken to complete each and every cycle by the body is exactly same. The definition meaning you are getting, that's why it is also example for periodic motion. And go to third example. Oscillation of a loaded spring. Oscillation of a loaded spring. Loaded in the sense this is a mass. You have to attach some mass to the spring. What is this one? Let us take, this is a support and this is a spring, and this is a spring. Let us attach some mass. Let us attach some mass here. Load means weight. M into G, that whatever you are getting, that is a load. Imagine now the body is in rest. This is a mean point. This is a mean point. Pull the body in downward direction. ಅಂದ್ರೆ ಕೆಳಗೆ ಜಗ್ರಿ ಬಾಡಿನ, ಅವಾಗ ಬಾಡಿ ಎಲ್ಲಿ ಬರ್ತದ? The body is, the spring is stretching like this. The spring is stretching here. Means this is extreme point. Again pull the body to a certain extent and release it. ಅಂದರೆ ನಿಮ್ಮ ಕೈ ಒಳಗಿಂದ ಬಿಟ್ಬಿಡ್ರಿ, ಅವಾಗ ಬಾಡಿ ಮ್ಯಾಗ್ ಹೋಗ್ತದ, ಕೆಳಗೆ ಬರ್ತದ, ಮ್ಯಾಗ್ ಹೋಗ್ತದ, ಕೆಳಗೆ ಬರ್ತದ. Again the body is moving here, means at this point it is coming. Again this is another extreme position. You already done with this experiment in the laboratory, physics lab. This is a spring, full in downward direction, release it, and it is moving up and down. Up and down means to fro, to fro. This is moving. Let us take it as a mean position. Pull the body, release it. It is moving upward direction and coming downward direction. Moving upward, coming downward. Means this is to, this is fro. This is to, this is fro. This is rest position, means mean point. To and fro along this straight line. This is also somewhat with very less amplitude. This is also straight line almost, but not exact straight line is there. This is just application of a to and fro motion along the straight line. Pull the body to a certain extent and release it. It is moving up, down, up, down, up, down like this. This is a reference point. Means before applying force the body is in rest. That point is called as a mean point. That point is called as a mean point or rest point. After applying some force and release it, it is moving up and down from its mean point. Getting? Let us take, this is moving from this point. This is half cycle, this is half cycle, this is 1 cycle, this is second cycle, this is third cycle, this is fourth cycle, so on goes on continuous. In the vacuum the body never stops. In the vacuum, if you are doing the experiment, the body never stops itself. This is first cycle. For second cycle again you are not applying any force, the body itself starting its motion. Again the body again started its motion itself. Third cycle, fourth, fifth, 6th, 7th, so on continuously. and you are doing the experiment in the vacuum, in the sense the body never stops itself. This is one cycle. For example, the time taken by the body to complete one cycle is, imagine, 1 second. Per second cycle again 1 cycle, 1 second. Per third cycle again 1 second. Per fourth cycle again 1 second. Per each and every cycle, how much is the time taken by this body? That is the same time. First cycle, time taken 1 second. Second cycle, how much time taken? 1 second. Third cycle, how much time taken? 1 second. Fourth cycle, how much time taken? 1 second. Fifth cycle, how much time taken? 1 second. Per nth cycle, how much time taken by the body? Again 1 second. Per each and every cycle given by this body along a straight line, about it means point, it is exactly same. ಬಾಡಿ ತಾನಾಗೆ ತನ್ನ ಮೋಷನನ್ನು ರಿಪೀಟ್ ಮಾಡ್ಕೋತಿರ್ತದ. ಪ್ರತಿ ಸೈಕಲ್ಗೂ ತಗೊಳ್ಳುವಂಥ ಟೈಮ್ ಏನಿರ್ತದ? ರೆಗ್ಯುಲರ್ ಇಂಟರ್ವಲ್ ಆಫ್ ಟೈಮ್, ಮೀನ್ಸ್ ಕಾನ್ಸ್ಟಂಟ್ ಟೈಮ್. ಸೇಮ್ ಫಾರ್ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಸೈಕಲ್ ದ ಮೋಷನ್ ಈಸ್ ರಿಪೀಟಿಂಗ್ ಇಟ್ ಸೆಲ್ಫ್ and the time taken by the body for each and every cycle is same. Andre regular interval of time it is maintaining. Therefore it is also example for periodic motion. And go to next one, fourth one, that is oscillation of that is oscillation of bob of clock. Old clocks you might have studied, that is the atomic clock. Inside that clock there has been a pendulum that is moving with a regular interval of time. Getting old time anna ನೀವು ನೋಡಿದಿರಿ, ಟೈಮರ್ ಅನ್ನ getting clock. Inside the clock there has been a movement of the pendulum, there has been a movement of the body along a straight line. Getting ಏನಾಗ್ತಿರ್ತದ, ಕ್ಲಾಕ್ ಒಳಗಡೆ ಆಲ್ವೇಸ್ ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್ ಲೈಕ್ ದಿಸ್. ದಿಸ್ ಈಸ್ ಒನ್ ಸೈಕಲ್, ದಿಸ್ ಈಸ್ ಅನದರ್ ಸೈಕಲ್, ದಿಸ್ ಈಸ್ ಥರ್ಡ್ ಸೈಕಲ್, ದಿಸ್ ಈಸ್ ಫೋರ್ತ್ ಸೈಕಲ್, ದಿಸ್ ಈಸ್ ದ ಫಿಫ್ತ್ ಸೈಕಲ್, ದಿಸ್ ಈಸ್ ದ ಸಿಕ್ಸ್ತ್ ಸೈಕಲ್, so on continuously. For each and every cycle the time taken by that pendulum is always same. Getting for each and every cycle the time taken by the pendulum of clock is always same. Pendulum of clock is always same, and continuously with respective of time the motion is repeating itself inside the clock, that pendulum. Therefore for each and every cycle the time maintaining by that clock, that pendulum of the clock is always same. That is a periodic motion. You remember please, what do you mean by periodic motion? Whatever it is the motion which repeats, it has to be repeats itself. ಅಂದ್ರೆ ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೀವು ಪೆಂಡ್ಯುಲಮ್ ಅನ್ನ ಜಗ್ ಬಿಟ್ಬಿಡ್ತೀರಿ, ಒಂದು ಸೈಕಲ್ ಆದ್ಮೇಲೆ ಒಂದೇ ಸೈಕಲ್ ಕಂಪ್ಲೀಟ್ ಮಾಡಂಗಿಲ್ಲ, ಸೆಕೆಂಡ್ ಸೈಕಲ್ ಏನಾಗ್ತದ ತಾನಾಗೆ ರಿಪೀಟ್ ಮಾಡ್ಕೋತದ. ಸೆಕೆಂಡ್ ಸೈಕಲ್ಗೆ ಮತ್ತೆ ನೀವು ಏನಾರ ಫೋರ್ಸ್ ಅನ್ನ ಅಪ್ಲೈ ಮಾಡ್ತೀರಿ? ನೋ. ಫಾರ್ ದ are you applying any external force on the body for the second cycle? No. Once you apply the force and that is enough. Once you apply the force, that is enough continuously, then the body is moving itself. The motion is repeating itself by the body with a regular interval of time. The definition of periodic motion is very important with example. Getting? These are four simple or common examples for periodic motion. The definition is motion which repeats itself with regular interval of time is called as a periodic motion, and these are the examples, and you can remember anyone. And next we can study the another concept. Next concept, that is the oscillatory motion or vibratory motion. Both are same. Sometimes you can heard the word as a vibratory motion or sometimes oscillatory motion. Both are same. And first we'll see the definition. What do you mean by oscillatory motions? It is to and fro motion. It is to and fro motion of the body, to and fro motion of the body from its mean point, or mean position or mean point called as vibratory motion or oscillatory motion, called as vibratory motion or oscillatory motion. What is the example? The first example, that is oscillation of simple pendulum, and you already studied about simple pendulum. The simple pendulum is example for periodic motion. You studied example for periodic motion is that is oscillation of a simple pendulum, and for oscillatory motion also a simple pendulum motion is a best example. That is, let us take, this is a simple pendulum, this is the object, and here this is extreme point, this is mean point, this is extreme point, this is also extreme point, this is also extreme point, and this is a mean point, and this is a thread, and this one is a support. And now the body is in rest, its velocity is equal to 0. Pull the body to a certain point and release it. After releasing, the applied force is acting on this body in this direction, the force is acting on the body in this direction, and the body is oscillating like this. The body is oscillating like this, and from the mean point, the displacement at this point is 0. If the body is moving, this is the displacement. If the body is moving, this is the displacement from the mean point. If the body is moving from the mean point, this is the displacement. If the body is reaching this final point, from the mean point, this is the displacement. This is extreme point, this is mean point. Whenever the body is in motion, this is first cycle, second cycle, third cycle, fourth cycle, goes on continuously. This is 2, this is fro, this is 2, this is fro. Again, this is 2, fro, again 2, again fro, 2 fro and 2 fro, 2 fro, again 2 fro. From which point? Mean point. This is mean point. This is 2 and this is fro. Again this is 2, again this is fro, 2 fro, again 2 fro. The to and fro motion of the body from which point? From mean point. From which point? From mean point. Mean point ದಿಂದ ಲೆಫ್ಟ್ ಮತ್ತು ರೈಟಿಗೆ ಏನು ಮಾಡ್ತಿರ್ತದ? ಟು ಆ್ಯಂಡ್ ಫ್ರೋ ಮೋಷನ್ ಮಾಡ್ತದ. ಟು ಮೀನ್ಸ್ ಫಾರ್ವರ್ಡ್ ಬ್ಯಾಕ್ವರ್ಡ್, ಫಾರ್ವರ್ಡ್ ಬ್ಯಾಕ್ವರ್ಡ್, ಫಾರ್ವರ್ಡ್ ಬ್ಯಾಕ್ವರ್ಡ್. To and fro motion of the body from its mean point is called as oscillatory motion or vibratory motion, and this is the example. And what is the second example? Again, oscillation of a loaded spring. Oscillation of a spring, loaded spring. That is also example for to and fro motion. Let us take, this is a support, and this is the spring, and this is the spring, and this is the object, and this is mean point. This is mean point, and pull it in downward direction. Downward direction the full madri. This is which point? This is extreme point. This is extreme point, and release the body. Again it is moving here. Again it is moving here. This is which point? Again this is extreme point. Again this is extreme point. This is from the mean point. This is to fro, to fro, to fro, to fro. From the mean points, the object is doing, the mass is doing to fro, to fro, to fro, to, fro. From the mean point it is doing to and fro motion, that's why it is also example for oscillatory motion. And third one you can take, that is vibration of string of a guitar. Vibration of string mean wire, metal wire, string of a guitar. As you know very well, this is the instrument getting you are going to use in order getting to in the music. Let us take, this is a guitar, this is a guitar wire, this is a guitar wire. Now it is in rest. This point is called as a mean point. If you disturb the wire of the guitar, by your finger, and this wire is vibrating, this wire is moving up and coming to the same point, moving down, coming to the same point, moving up, down, getting down, back, up, back. Now this is now the wire is in rest. This point is called as a mean point. This position is called as a mean point. If you disturb the wire by your finger, then the wire is vibrating like this. The wire is moving up, means this point is called as a extreme point. Again wire is coming to the same point, called as a mean point. Again wire is moving in downward direction. Again wire is moving in downward direction. Again this point is called as a extreme point. If you disturb this wire, it is moving up, again coming down, again moving down, again coming to the same point. Again this is to, this is fro, this is to, fro, this is to, this is fro. From mean point to and fro motion, from the mean point to and fro motion. That's why it is also oscillatory motion or vibratory motion. And these are common example for oscillatory motion or vibratory motion. And revolution of earth around sun is not oscillatory motion. It is periodic but not oscillatory motion. This is not a oscillatory motion. The fourth one is not a oscillatory motion. This is oscillatory, this is oscillatory, this is oscillatory. Let us take this is to fro. Yes, this is oscillatory motion. Here to fro. Yes, it is also oscillatory motion. And here from the mean point to fro, this motion is called as again vibratory motion or oscillatory motion, both are same. But revolution of earth around the sun is not a oscillatory motion, but it is a periodic motion. And here this is sun and this is the earth. This is not a to and fro motion. This is a circular motion. This is circular motion. This is circular and not oscillatory. You don't confuse with this one. This is periodic. The motion which repeats itself for one cycle, same time, per second cycle, same time, per third cycle, same time, fourth cycle, same time. The motion is repeating continuously itself, and for each and every cycle around the sun, the time taken by the earth is the same, but it is a periodic motion, no doubt at all. The revolution of earth around the sun is a periodic motion but not a oscillatory. Oscillatory in the sense, the condition should be that is to and fro. ಟು ಆ್ಯಂಡ್ ಪ್ರೋ ಕಂಡೀಷನ್ ಇರಬೇಕಾ ಆಸಿಲೇಟರಿ ಅಂತ ಹೇಳಬೇಕಾದಾಗ, ಬಟ್ ಇದರೊಳಗಡೆ ಟು ಆ್ಯಂಡ್ ಪ್ರೋ ಕಂಡೀಷನ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಂಗಿಲ್ಲ. ದ್ಯಾಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ನಾಟ್ ಅ ಆಸಿಲೇಟರಿ ಮೋಷನ್, ಬಟ್ ಇಟ್ ಈಸ್ ಅ ಪೀರಿಯಾಡಿಕ್ ಮೋಷನ್, ಆರ್ ಯು ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್, elliptical motion. It is a elliptical motion. It is not a to and fro. It is a periodic motion. Getting the periodic motion and oscillatory motion, both don't confuse. Getting these three are oscillatory or vibratory because the to and fro condition is satisfying to this one, and to this one, but not to this one. That's why it is a periodic motion, but not a getting oscillatory motion. This is also periodic, this is also periodic, this is also periodic. This is oscillatory as well as periodic, oscillatory as well as periodic, the oscillatory as well as periodic motion. It is not oscillatory, it is a periodic but not oscillatory, periodic as well as oscillatory, periodic as well as oscillatory, periodic as well as oscillatory. There has been a condition, you remember that one. What is that condition? What is that condition? That is all the oscillatory motions are periodic. All the oscillatory motions are periodic. Motions are periodic. All the oscillatory motions are periodic, but all periodic motions may or may not oscillatory. Motions may or may not oscillatory. May not oscillatory. What is the meaning of this sentence? ಎಲ್ಲ ಆಸಿಲೇಟರಿ ಮೋಷನ್ ಏನಾಗಿರ್ತಾವ, ಪೀರಿಯಾಡಿಕ್ ಆಗಿರ್ತಾವ. ಹೆಂಗೆ ಪೀರಿಯಾಡಿಕ್? ದಿಸ್ ಇಸ್ ಆಸಿಲೇಟರಿ ಮೋಷನ್. ಒನ್ ಸೈಕಲ್ ಸೇಮ್ ಟೈಮ್, ಸೆಕೆಂಡ್ ಸೈಕಲ್ ಸೇಮ್ ಟೈಮ್, ಥರ್ಡ್ ಸೈಕಲ್ ಸೇಮ್ ಟೈಮ್. ಎಸ್, ಇಟ್ ಈಸ್ ಪೀರಿಯಾಡಿಕ್. ದಿಸ್ ಈಸ್ ಆಲ್ಸೋ ಪೀರಿಯಾಡಿಕ್. ಒನ್ ಸೈಕಲ್ ಸೇಮ್ ಟೈಮ್, ಸೆಕೆಂಡ್ ಸೈಕಲ್ ಸೇಮ್ ಟೈಮ್, ಥರ್ಡ್ ಸೈಕಲ್ ಸೇಮ್ ಟೈಮ್. Yes, it is periodic. Here it is also periodic. All the oscillatory motions are periodic, but all periodic motions may or may not oscillatory. ಎಲ್ಲ ಆಸಿಲೇಟರಿ ಮೋಷನ್ ಪಿರಿಯಾಡಿಕ್ ಆಗಿರ್ತಾವ, ಬಟ್ ಎಲ್ಲ ಪಿರಿಯಾಡಿಕ್ ಮೋಷನ್ ಆಸಿಲೇಟರಿ ಮೋಷನ್ ಆಗಿರ್ಬೋದಾ ಅಥವಾ ಆಗದೇ ಇರ್ಬೋದಾ? What is the example? The example, that is, what is the example? The example, you remember revolution of earth around sun is periodic. Revolution of earth around the sun is periodic, but not oscillatory, because the revolution of earth around the sun is not having a to and fro conditions along its motion. Take the example, revolution of earth around the sun is, yes, periodic. That is periodic. For each and every cycle it is taking the same time and the motion is repeating continuously. Revolution of earth around the sun is a periodic but not oscillatory, because this is a circular motion or elliptical motion. The revolution of earth around the sun is a elliptical motion and continuously that is revolving. That's why that is not oscillatory. To and fro condition is not there in a revolution of the earth around the sun. That's why that is not oscillatory, but that is a periodic motion. And here condition, you remember, all the oscillatory motions are periodic, but all the periodic motions may or may not oscillatory. ಎಲ್ಲ ಆಸಿಲೇಟರಿ ಮೋಷನ್ ಪಿರಿಯಾಡಿಕ್ ಆಗಿರ್ತಾವ, ಬಟ್ ಎಲ್ಲ ಪಿರಿಯಾಡಿಕ್ ಮೋಷನ್ ಆಸಿಲೇಟರಿ ಆಗಿರದೇ ಇರ್ಬೋದ. ಬಟ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡ್ರಿ, ರೆವಲ್ಯೂಷನ್ ಆಫ್ ದ ಅರ್ತ್ ಅರೌಂಡ್ ದ ಸನ್ ಅನ್ನೋದೇನಿದೆ ಪಿರಿಯಾಡಿಕ್ ಮೋಷನ್, ಬಟ್ ಅದು ಆಸಿಲೇಟರಿ ಅಲ್ಲ. ಆಸಿಲೇಟರಿ ಅಂದ್ರೆ ಟು ಆ್ಯಂಡ್ ಪ್ರೋ ಇರಬೇಕು, ಬಟ್ ವೆನ್ ಎವರ್ ದ ಅರ್ತ್ ಈಸ್ ರಿವಾಲ್ವಿಂಗ್ ಅರೌಂಡ್ ದ ಸನ್ ದೇರ್ ಈಸ್ ನೋ ಟು ಆ್ಯಂಡ್ ಪ್ರೋ ಕಂಡೀಷನ್ಸ್ ಆರ್ ದೇರ್. ದ್ಯಾಟ್ಸ್ ವೈ ದಟ್ ಈಸ್ ಪಿರಿಯಾಡಿಕ್ ಬಟ್ ನಾಟ್ ಆಸಿಲೇಟರಿ. ಯು ರಿಮೆಂಬರ್ oscillatory motions and examples, and periodic motions and examples, and that condition, that is important in order to better understand the concept. And these are three examples for oscillatory motion, and the last one is example for periodic motion. This is example for periodic motion but not oscillatory. Getting? Next we can study about the concept as simple harmonic motion in the next class. Note down please.